Oh, 1 minute. Okay. Oh, we're going to start in 1 minute? Oh, okay. All right. So, first of all, a big thanks to Frank Townsend, who does a great job of doing all this for us, getting it on so that we can see it at a later date, or so that other league members can see this. Thank you very much. And I'd like to welcome Janice Geary, who's the president of the local League of Women Voters. Janice, you want to come up and say a couple words? And while she's coming up, I have one more thing to say. On our next meeting, March 14th, we will be talking about and reading banned books. Won't that be fun?
Well, I hope you're allowing plenty of time for that meeting. My name is Janice Geary. I am the president of the League of Women Voters of Alachua County. And I just want to tell you that you folks are incredibly fortunate to have June Garrard and Mary White. How's that? Oh.
Hey, that was so much better.
You're so fortunate to have June Garrard and Mary White here because they are both such wonderful people, and they are just really, they're fun people, but they also have in their heart the League of Women Voters, empower voters, and defend democracy, and that's what we're all about. So I'm very excited about this talk. If you have not yet signed the Right to Clean Water petition, there's some charming, gorgeous women back here at the table who will help you do that. It's an extremely important amendment going on the 2024 ballot to make it a fundamental right of Floridians to have clean water. Now, does that not strike you as a no-brainer?
Yeah.
Thank you, Janice. I just saw that we have cookies, finally. Yep, cookies. It's my pleasure to introduce today's speaker, Philip Benson, who comes to us from the St. Johns River Water Management District located in Palatka. So he drove out from Palatka today just to give us this talk. Philip is a hydrologist in the Bureau of Water Resource Information and oversees the district's groundwater monitoring network. He began his career at the district in 2005 as a chemist before taking on other roles such as environmental scientist and field program supervisor. He has over 17 years of experience specializing in the areas of data collection, quality assurance, interpretation of environmental data, and water use permitting. He holds a bachelor's degree in biology and chemistry from FSU and a master's degree in geosciences from Mississippi State University. Please welcome Philip Benson. He's
Okay, is it working now? Okay. All right, and as I was telling Pushpa, I married into the Gators, so I'm half accepted now. So, okay, I can scoot a little closer. Is that a little better? Okay. Well, thank you, Pushpa, for that introduction, and thank you again for the invitation to talk to you about the Floridan Aquifer, Florida's biggest water body. I have a lot of material I'd like to cover today, so if we could maybe save questions for the end, I think we should have about 15 or 20 minutes. I can always go back to slides if you'd like to review something. Okay. I can. Okay, it's on. How's that? I can lean in. Can everybody hear me okay? Okay. All right, so through today's presentation, I hope to tell you something you've never heard before, and maybe you can, in the question and answers at the end, tell me something I've never heard before. I'm always interested in learning new things. So I'd like to start out telling you a little bit about the district, the Water Management District, who we are, what our goal is. I'll tell you a little bit about where Florida came from and how the Floridan Aquifer came to be. And then I'll finish up with some of the work that our amazing staff are doing to help protect this precious resource. The St. Johns River Water Management District was established in 1972 by the state legislature. A 9-member governing board establishes policy, executes regulatory authority, and hires the executive director who oversees daily operations. Okay. I just shut off. No, it just turned off as well. Is that maybe a low battery or something? I think we have a low battery. Shut off again. Wow, isn't that something? Okay. Oh, this one has tape on it. It must work better. Yeah. Okay. Okay. All right. So the governing board, they meet the second Tuesday of every month. The board meetings are open to the public if you're interested in joining us at the Palatka headquarters. It's also broadcast online if you guys are interested to see what they're discussing. Again, that's the second Tuesday of every month. It's also broadcast online. I think I said that. So. Okay, the St. Johns River Water Management District includes all or part of 18 counties in Northeast and Central Florida. It incorporates over 12,000 square miles of land. It's almost 8 million acres. It's about 21% of the state. If you're wondering why the district boundary includes part of some counties, that's because Alachua County, for example, is shared between the Suwannee District and the St. Johns District. That's because the district boundaries were established based on surface water basins, which in short means any rainfall runoff within these boundaries is going to flow into one of the surface water bodies within the district. In addition to the St. Johns River, other significant water bodies include the St. Mary's and Nassau Rivers to the north, the Matanzas and Halifax Rivers in the central coastal region, the Indian River Lagoon in the southern coastal region, and the Ocklawaha River on the western border. We have 148 springs in our district, as well as over 1,400 lakes. The district has some regulatory authority. We issue 3 main types of permits to help protect the environment as development occurs. Consumptive use permits authorize withdrawals of groundwater and surface water for reasonable beneficial uses, things like public supply, agriculture, irrigation, and power generation. Environmental resource permits are designed to ensure that new development and construction activities can occur while preventing adverse flooding and protecting water quality. Water well construction permits are either issued by the district or one of our delegated county representatives to drill, repair, or abandon groundwater wells. We've got about 500 folks working for the district, both scientific and non-scientific backgrounds. Many of our staff have years and years of experience in both the public and private sector. We've got quite a few staff that have been recognized for their great work locally, nationally, and even internationally. And finally, the district's overarching mission, I'll read it to you here, to protect our natural resources and support Florida's growth by ensuring the sustainable use of Florida's water for the benefit of the people of the district and the state. To accomplish this mission, our work is focused on 4 core missions. Water supply is ensuring sustainable water supply for future needs for both the humans and the environment. Flood protection is preventing increases in flooding and managing our existing flood control projects. We are protecting and improving water quality and protecting our natural systems. You can't really see here. So this is the fun stuff. When you hear the word geology, you probably think of what, mountains, earthquakes, maybe the Grand Canyon. We don't have a lot of that here. So Florida's been appropriately designated the flattest state. So not surprising, the highest point in Florida is the lowest high point of any state. Maybe when you hear geology, you just simply think of rocks. But I'm more likely to find rocks in the garden section at Home Depot than in my backyard. So just because you can't see it doesn't mean it's not there. Geologically, peninsular Florida, the part of the land that we live on, is perched on top of what geologists call the Florida platform. This is a thousands of feet thick sedimentary rock that was built over millions of years. So we actually live on top of a mountain. 650 million years ago, Florida may not have been the ideal retirement destination that it is today. You see it was down here, the little pieces of continental crust that would become Florida were down by the South Pole, sandwiched between, what would become South America and Africa. Eventually, continental drift brought all these continents together around the equator. This is a supercontinent called Pangaea. You can see future Florida is here in red. And this is also when the Appalachian Mountains first formed, and that'll be important here in a little bit. So as the supercontinent Pangaea broke up, Florida was now attached to the North American continent, where we are now. And it was underwater at that time. And the marine life just thrived in the warm, clear waters above it. The sediment that built this mountain that we're living on is mostly skeletal remains of things like coral reef, mollusks, sea urchin, anything with a shell or bones. This is actually happening right now in the Bahamas. Again, warm, clear water. We've got coral reef forming. Again, anything with bones or a shell, it's living, dying, settling. This may eventually, become an aquifer itself. And this is probably a lot like what Florida looked like millions of years ago. Over geologic time, those skeletal remains were compacted and cemented together to form limestone rock. The limestone Floridan Aquifer underlies the entire state of Florida and parts of Alabama, Georgia, and South Carolina. So if you remember, the Appalachian Mountains had formed. Now they've been eroding all this time, and they've supplied enough sand, silt, and clay to actually cap the limestone aquifer with this sort of this clay material that doesn't allow water to pass through it very well. So in areas where that still exists, it's said to be confined. This dark blue and kind of light blue. Here, the lighter color, it's said to be unconfined. That confining layer has been removed by some erosion. So pay attention when we talk about springs. This area here will have some meaning. So remember the kind of shape here. If you were to look at a map of the Suwannee Basin to the west here, where there's the confining layers either really thin or non-existent, there'd be a real lack of surface water features. That's because rainfall can just go straight into the aquifer. In contrast to our district to the east, the confining layer is still present. It allows surface water to remain at the surface, supporting lakes, streams, and rivers. In our district, 3 major aquifers are used for groundwater sources. From the top down, the superficial aquifer system exists in a thin layer of quartz sand that is also eroded from the Appalachian Mountains. In some places, there's a water body that is confined both above and below. We call this the intermediate aquifer system. And then below that, we have Florida's largest water body, the Floridan Aquifer system. This freshwater layer is thicker in the center of the state, and it rapidly thins towards the coasts and to the south. You'll see deep throughout the entire aquifer, there's this layer of salt water deep down below. This is all over. Yes, ma'am. Oh, sure, of course. Yeah. Mm-hmm. So water discharges naturally from the aquifer through springs. However, most of it is removed from the aquifer through pumping of wells. Water stored in the aquifer is recharged, replenished through rainfall. Florida, on average, gets around 51 inches per year of rainfall. About 38 inches of that either evaporates or runs off into surface water. The remaining 13 inches or so is available to refill the aquifer. This recharge is much more efficient in areas where this confining layer is thin or absent. As the rainfall travels through the atmosphere and percolates through the soil, it naturally picks up carbon dioxide and becomes mildly acidic. This mildly acidic water can dissolve the limestone rock within the aquifer and enlarge small cracks and fissures into massive conduits and underground rivers. This process is called karstification, and it's one of the reasons that the Floridan aquifer is may be the most productive aquifer in the world. Some of these karst features can be seen at the surface in the form of springs, swallets, and sinkholes. So a sinkhole may form, after a significant drought, an underground cave like this. Water levels are low. The sediment overlying this cave can slowly erode and collapse. This happens when water level is low because the water pressure, when this cave was full of water, the water pressure tends to help support the sediment above it. These can also happen after significant rainfall, especially immediately following a drought. The inundation of the rain on the overlying sediment can add weight, which can cause a collapse. So sinkholes like this one in Winter Park, they make it to the news, but they really don't happen that often. Okay, go for it. She asked if we could predict when a sinkhole might happen. There are methods to detect underground caves. There's ground penetrating radar. Sometimes you accidentally discover something when you're drilling a well. But more often than not, no. Very often a sinkhole may be observed at the surface as a little subsidence. Cracks in your walls of your house or creaking sounds. Sometimes you can, they don't always just collapse all of a sudden. Oftentimes they're just smaller openings like these seen here. If you'd like to see a sinkhole in person, Devil's Mill Hopper is not that far from here. There's an observation platform at the top. I know hiking in, there's a really nice set of stairs. Hiking in is nice, but hiking up is good exercise, so just beware. A swallet is basically a sinkhole where a stream abruptly empties into the aquifer. These are also referred to as disappearing streams. This one is Mill Creek. It's not far from here. It's up near I-75 and US 441 in Alachua. It's working, Frank. So this is in Olino State Park. If you'd like to go see a swallet, this video has been sped up for effect. The turtles are having a tough time of it. But here the Santa Fe River enters the underlying rock and it travels over 3 miles underground before re-emerging in River Rise State Park. You can't see the rock, but this whirlpool motion, would be just like in your bathtub or shower as the water's going down the drain. These poor turtles. That's just vegetation on top. Here's another example. You can actually see the water entering the rock. This is on the Suwannee district, up north on the Alapaha River. Yes, it's freshwater, yes. A spring is a point of focused groundwater discharge. It's where groundwater actually becomes surface water. Water from springs supports a base flow for many streams and rivers and habitats for fish and wildlife like manatees and alligators, turtles, variety of birds, and you can name 100 more. There are over 1,000 named springs in the state of Florida. They all occur north of this line here in the northern part of the state. If you recall from the that map of the confining layer, remember it was unconfined over here in the Suwannee area and semi-confined in this area. So springs are located, they're concentrated where the aquifer is near the surface or the confining layer is thin. All right, so this video is it's a 2-minute clip from a documentary called Water's Journey. There's some karst features like underground rivers and caves we can't see from the surface, but these scientific divers actually entered the aquifer through a sinkhole and were able to capture video images of what the aquifer looks like right here in Gainesville. So it's about 2 minutes long. Yeah, good thing.
This is a gorgeous example of a disappearing stream. Okay, incoming.
The team starts their journey in North Florida. They will be traveling over and through karst terrain, a limestone landscape that is characterized by caves, fissures, and underground streams. The goal: to navigate the complex system of underground rivers from where water disappears underground to the point where it resurfaces in Florida's springs. Each dive will require up to 2 miles of swimming and hours of decompression time.
Can you hear me okay?
Jill and Tom will be in contact with each other through wireless communications in their masks. But because of depth and the thickness of the rock over their heads, they'll be out of voice communication with the surface. Their experience is a mystery to the rest of the team until they come up. The state of Florida is a literal Swiss cheese of water-filled labyrinths. Exploring and monitoring the inside of these seamless conduits not only takes courage, but also one of the most refined skill sets of any occupation.
Well, the tunnel really seems to be opening up a little bit here. Definitely getting bigger, Tom.
Yeah, we get bigger here.
Oh my God. Will you look at that?
There goes 4K.
Woohoo! This is our entry into the Floridan Aquifer, Tom. What a place. That is phenomenal. I don't think I've ever seen a drop like this.
Yeah, looks like we're fixing to drop down to 50 million years of limestone.
It's amazing and terrifying, right? There's no way out except back. This documentary has several different versions. It's on YouTube, and you can watch them reemerge at a spring. So they do make it out safely. The surface team developed a technology to track these divers underground. So they were following them at the surface. It took them through golf courses and neighborhoods, and even through a restaurant. So this is about a minute long. Oh, here we go. Can you play that one, Frank? There we go.
This is great.
Looks like it's going to go underneath.
Right into the building, huh?
Yep, right into the building. Right underneath.
That's radical.
That's it.
Come on.
Okay, we're still got
They're still down there right now?
Yep.
You got
We'll have to go down here to pop them up. Yep,
So they're right here.
Yep. They're right under us. They're going to go. I think they're going this way.
Excuse us. Underground survey in progress.
Heading towards the salad bar.
Towards the salad bar.
Well, it's been almost 3 hours we left that sinkhole.
When do we stop for lunch?
It's pretty amazing. So, I mean, you can see how much water is down there and in places. In fact, this was up also near 441 and 75. They traveled about 3 miles. I think they were headed west from there. There's a lot of water down there. I think they referenced their depth a few times in the video. They're about 80 to 100 feet below ground. So now that we've learned about the Floridan Aquifer, I can talk a little bit more about some of the work that the district is doing to try and help protect it, and manage the resource. The easiest way to think about it is like a bank account. Our income is rainfall. Water levels in the aquifer help us to kind of check the account balance. And withdrawals and expenses are in the form of springs and wells. So there's this balancing act between using it for ourselves and leaving enough water in the balance for healthy natural systems. I'll talk in a little bit about the planning process for human use, but for natural systems, our process. Our process for determining water needs is called minimum flows and levels, or MFLs. That makes it to the news quite a bit. You may have heard that term before. But minimum flows and levels establish a limit to water withdrawals to prevent adverse impacts. And MFLs are just one of the many tools we use to help manage the resource. Now, we cannot effectively manage the Floridan Aquifer without really knowing what's going on down there. Many of our staff are responsible for collecting massive amounts of data. Each year, more than 16 million measurements are collected, validated, and stored. We collect rainfall data. We collect water level data in all of the aquifers. We measure spring flow data. And our permitted water users are required to tell us how much water they use. And not only do we need to know how much is in there, we also need to know if it's any good. So the district has its own lab. This is Curtis. He helped train me when I started at the district. But we have our own lab at the Palaca headquarters office, and water quality samples are sent in from all over the district. We have hydrologic data collection specialists who use this highly complex acoustic Doppler current profiler, we call it the ADCP, to measure stream flow. And we also contract with licensed well drillers to help us with aquifer investigations. So the group that I am, we're called the Hydrogeologic Services Group. We drill exploratory wells, we install new monitor wells, and we investigate existing wells. In this well being drilled near Little Orange Creek here in Alachua County, one of our technicians is reviewing these core samples. These are little bits of the rock in the aquifer. These are collected during well drilling, and they can help us kind of see how deep the aquifer goes, the extent of the aquifer, if the confining layer is present and how thick. Some other important data we can get from these rocks is called porosity. We need to know if the rock can hold water. Another important piece of data is the permeability. So it can hold water, but can water flow through it? So that helps us to determine water availability in an area. After a well is drilled, geophysical logging may be performed to give us a better picture of what the aquifer looks like in that area. A highly complex tool like this here, it's about as tall as me, is lowered into a borehole of a well and records data. So gamma logs and electric logs are very commonly used in aquifer investigations. The gamma log records naturally occurring radiation emitted from the material encountered in the well. So clay, for example, emits more radiation than limestone. So you can really see the clay confining layer stands out here. A good electric log would, this is electric resistivity. It can give us an idea about the characteristic and thickness of the rocks we encounter. It's kind of covering up a picture here, but there's at the bottom of this graph, where there's a spike and it's more resistive, it may indicate that the rock is more compacted or more cemented, so there's less water available in that part of the aquifer. So what can we do with that data? We can create a cross-sectional view of the aquifer using the core sample data and the geophysical log data. You can really see here that the layers of the aquifer may not have been deposited very evenly, or they may have changed over time. This could help guide us in where we might want to install new monitor wells or even public supply wells. From west to east, we have Lake County, Orange County into Seminole County, and you can see that clay confining layer. This is the Hawthorne group. It's non-existent here in Seminole County, and then it's offset. So, that's good to know, especially for drilling new wells. So to check our account balance, the district maintains a network of monitor wells, over 740. And these monitor water levels in all of the aquifers, the superficial aquifer, intermediate, and Floridan Aquifer. Here's an example of one of our monitoring sites. This is actually at Alachua County Fairgrounds. We have a rain gauge here, and we have wells. We monitor water levels in both the superficial aquifer and the Floridan Aquifer system. The equipment here records data continuously, and it reports data back to the district every hour. These sites are all solar powered because they're often far from your typical power source. Some of these are only accessible by 4x4 truck or ATV, hiking. We've even got a couple you have to use a boat to get to. And inside the lockbox is the battery system, a small computer, and actually a cell phone. So we just use regular AT&T Verizon to transmit data. Now here's one of my favorite examples of water level data. This is called a hydrograph. And this is from September of 2017. And I love to share this example because there was a lot going on that month. So we have dates along the bottom, and our scale is in feet above mean sea level. So water level here was around, 68 to 70 feet above mean sea level. So as we're reviewing the data, the first week is pretty typical water level data. It moves up and down a little. There's not much going on. And then we get this spike. And we were baffled. My team and I, we were reviewing the data and noticed that a similar spike, both up and down, were happening in wells across the district. And we couldn't figure out what was going on. It was the same time, same place. And then we found out on the news there was an earthquake in Mexico, over 1,000 miles away. The shock wave traveled through the earth, and when it got to us, it had some sort of effect on water levels. Yeah. And again, September 2017 was a busy month. So we have another big spike, not another earthquake. Can anybody remember September 11, 2017, a big weather event? Yeah. Hurricane Irma. The low pressure in the eye of the storm was so significant, it lifted the weight of the atmosphere, and the water level in the aquifers actually rose to meet it. As it passed, you can see it gradually returned. Absolutely incredible. And then we got a bonus. All that rainfall recharged the aquifer. It went up a foot just in that month, and it kept going up. We could use more of these, minus the wind. Of the 740 monitor wells, about 468 of them are sampled for water quality. We analyzed the samples for a whole suite of different kinds of things, but I'd like to talk a little bit about chloride or salts today. In some places, the water in the aquifer is, it's not suitable for drinking without some sort of treatment. So, we mentioned earlier that there's salt water deep down in the aquifer all over. Saltwater intrusion is when salt water enters your freshwater well. This can happen when a well is drilled too deep. Maybe you got too close to the salt water. Or if you pump too much fresh water, the salt water can actually move in to take its place. So, I mentioned we drill wells and take core samples. We also collect water quality at different depths, and in some places we can tell you where the fresh water changes to salt water. And it's not a fine line. It gradually changes in most cases. So we collect at different depths to see where that saltwater interface is at. We also collect water quality samples continuously. So these are all sampled annually to see if water quality changes over time, as we might expect with sea level rise. Lateral saltwater intrusion can become an issue for coastal wells. So in this graph, we kind of put together all of the geophysical and core data to display the superficial aquifer and that upper confining unit. That's the clay layer we talked about. In the Floridan Aquifer in places, there's also some additional confinement. And then we have the yellow and the green are the water quality information on top of that. So we can tell you about where that freshwater saltwater interface is at. And remember, I said the freshwater layer is thicker in the center of the state and it thins towards the coast. And again, this is useful information in determining where to drill new wells. So water conservation is an easy way to manage the aquifer, not to mention more cost efficient than alternatives. And water conservation really is the foundation to meeting our future water supply needs. So that's why our governing board has dedicated staff and funding to the Abandoned Artesian Well Plugging Program. Many of these free-flowing wells are kind of a relic of the past. Agriculture operations would use these for irrigation, and they're no longer needed. So not only are they wasting water, but as these wells age, they can fracture, and if they're deep enough, allow some of that salt water to move up and contaminate our freshwater sources. So it's critical that we go in and plug these wells. We just fill them with cement grout from the bottom up. This is all done at no cost to the homeowner right now. We're really encouraging folks to reach out and ask for help. We've abandoned over 2,900 of these since 1983. We're saving an estimated 764 million gallons a day. So the governing board is happy with this project, and it's going to be funded for a long time. Do I know how many are left? We have no estimate, but we are getting calls every day. We've got 3 field guys who are going out sometimes every day of the week. Most of these are down south in the Palm Bay kind of region. But yeah, there's so many that we don't know about. Yeah. Okay, I'm getting to the end. There's a couple programs I'd like to mention, not in my group, but I think they're worth mentioning. So I mentioned the minimum flows and levels is the natural system side of this balancing act. The other side is public supply, a human need for water. And our water supply planning group evaluates projected needs based on projected growth. In places where water supply is limited, usually by an established minimum flow level, they can recommend alternative water supplies or conservation to try and meet that need. Because the aquifer does not have a political boundary, we partner with our neighboring agencies as well. You see Alachua County is in the partnership between the Sewanee District and the St. Johns District called the North Florida Regional Water Supply Partnership. Another extremely successful program at the district, our governing board fully supports this. We are helping fund cost share projects. We match funds for projects that would support one of our core missions. And some of these examples would be a local utility, maybe replacing aging or leaking water transmission lines as a water conservation measure. We have farmers that are improving their irrigation systems to save water. We've got some utilities also extending their sewer lines to eliminate septic tanks. So we're improving water quality in areas. This is an annual, there's an annual competition, you apply, and there's some really great projects, and we'd love to approve all of them, but our funding is limited. So we're going to keep going with this project as well. So everything I've talked about in the last half of the presentation here, all the data is available on the district website right here. I'd encourage you guys to go check it out if you want to learn more. You're welcome to give me a call or send me an email if you have questions after tonight. But for now, I think we've got about 10 minutes or so. I can stay later if you want for questions.
Yes. I saw it.
Hang on.
Thank you. I saw a presentation perhaps 10 years ago that discussed the impact of the water being withdrawn from Jacksonville, especially on our own locale. And they showed a very nice graph about how the intrusion of salt water is gaining on us and continues to, I'm sure, right?
There's a lot of talk right now about saltwater intrusion. It's been more of an issue with the South Florida and Southwest Florida water management districts. The geology is a little different down there. We do have some, if you're talking about lateral intrusion from the ocean, we have a little bit from in the Flagler County area. I know JEA specifically has the vertical intrusion. Some of their wells, they pump so much water that they're actually getting salt water from below. and they have an aquifer management program that they monitor the water quality, and whenever they see the chlorides going up, they'll move to a different well field and try and manage that.
So what would be the effect of the rising waters, the ocean rising, seawater rise due to climate change?
So salt water is more dense, it's heavier than fresh water, it would displace the fresh water. So, it would happen along the coasts first, so that could really impact our available fresh water supply.
I'd like to talk about what's happening kind of right now. It's pouring down rain in Georgia. If it continues like that, and we're not getting that rain, are we getting the water from the what do you call it, the freshwater basin? Is it coming from Georgia, continuing to come toward us? Or can they pump it up before it gets here? In other words, can we lose fresh water, or should we working to keep a partnership?
That's a great question. In fact, the general flow of groundwater has changed since Florida has been developed. I wish there's some great images from some older publications. The U.S. Geological Survey has some really great maps on that, where the flow generally was from the center of the state towards the coast, and with development, there's some changes in flow, like towards the Jacksonville area, for example, since they're pumping so much. But as far as I can't tell you across the border. My studies have been just within Florida, so I can't answer that all the way for you. So the Floridan Aquifer is connected. So at some point we will have to work with Georgia. In fact, the North Florida. I can go back here. Can we go back, Frank? No. Yeah, no, that's okay. So when I talked about the water supply plan, the North Florida Regional Water Supply Partnership, they've adjusted their modeling efforts. They have numerical models to predict water availability, and it's now including parts of Southeast Georgia. So they are starting to look at that.
You mentioned there were 1,400 plus lakes in the district. To what extent were they created by, do you think, by subsidence or collapse?
It's a very good question. There are some.
I guess.
There's some you could say were obviously created by subsidence. The perfect circles, Central Florida, Orlando, and to Leesburg, that area, most of those are old sinkholes. Yep.
Is conservation of water very important? Because we're supplying water just in Florida to over 20 million people plus the other areas. So what kind of conservation would you suggest that we follow?
That's a very good question. I think, like you and I spoke before, water conservation is really the key to our future water supply needs. I think I could recommend somebody else to give an entire presentation just on that. So that's outside of my expertise.
On the slide that you showed with the little guy on the tightrope, and economic benefit was on one side and natural systems was on the other side, and this is kind of related to her question. I was wondering where residential use fits in natural systems or economic benefit. And can I comment on her?
Yeah, go ahead.
Okay. It said that at least 50% of residential water use is used to water lawns.
Mm-hmm.
So there certainly is a place that we could conserve. But anyway, I'm curious about my question too.
So it's funny, the governing board met today and that actually came up in discussion. I know there's a lot of residential wells installed just for irrigation. They may get their drinking water from the local utility, but then use a well to irrigate. The district has a difficulty getting a grasp on estimating that amount of use. So I could only speculate that there may be some new policies made towards that.
And what about the residential use? Where does that fit between financial?
Oh, residential is definitely on the economic side of that. Yep. And we do, the water supply plan folks, they gather information on homes with wells. So when a well is drilled, they have to submit a well completion report to the district. So we know where most of the wells are. Some people don't follow the rules, but we know where most of them are, and we have just kind of a general estimate for water use for residential communities.
Is any member or representative of the Water Management District called upon in building and zoning discussions or hearings? Do you participate in that? Do you give information? Does anybody care?
I think I can respond, but I'm not sure I can answer that question. So we have what are called intergovernmental coordinators, and they are keyed in with local leadership on hot topics, new development, things like that. Eventually, once a local government has approved a new development, for example, the construction would still need to go through our district in the environmental resource permitting process. So if there was anything going on, significant impacts would have to be mitigated to get that permit approved.
Last question here.
If you could do anything you wanted to in your district, what would you do differently about how water is used?
Oh, wow, that's a good That's a big
I'd say we waste a lot of water. I know we have a whole public relations group, and we have media outreach, and I think we could just do better at sharing the water conservation message. You learn in elementary school to turn the water off when you're brushing your teeth, but that's not even a drop in the bucket compared to some other uses. So I'd like to see us be more careful with how we use it. Yeah.
Thank you very much. Really appreciate your coming out here.
Thank you all for coming. I hope you found this as interesting as I did. And turn off the water.
Thank you.